Hey everybody, in this video we're going to talk about scales of measurement, or put it differently, how do we classify the ways that we can assign number to people? So when you're using a tool, when you are creating your own tool, um, what is it that you're getting at, right? When you're thinking of the construct that you want to measure and evaluate, what is it that you're measuring? And so we can measure a variety of human attributes. That's psychology. We want to measure something about people, and it can vary. It can be emotions, it can be intelligence, personality traits, um, states and traits. For example, burnout is a state, right? Being angry is a state, or also a trait in that case, and so on and so forth. We want to put some quantifiable number to it through measurement. We're in psychometrics, we're talking about the study of measurement. So we have to assign numbers to this through some set of rules. And we rely on a fundamental assumption. Really, psychology relies on a fundamental assumption that if something exists, it must exist in some amount. And if it exists, it must be quantifiable. So we do sometimes a bad job, sometimes we do a really good job at quantifying something, but when we go from that theoretical to that operational construct, operational definition that we talked about before, we're saying, here's how we're measuring it. Something is there, theoretically, and we operationally define our measurement somehow. So we have to scale it somehow. We have to assign a number, and we want to be deliberate about this. Now, oftentimes, something like a 1 to 7 type scale, strongly disagree to strongly agree, works. That's common. That's oftentimes perfectly acceptable. Sometimes we have a 0 in the scale. We want to be deliberate about this. What does, for example, a 0 mean? Now, a 0 could mean you literally have nothing of something, but if that's the case, you want to include that thoughtfully. So there's a theoretical thought that goes into this. What does 0 mean? Is having a score of 4 really double than having a score of 2? It depends. If I ask you, how many office items did you steal in the last month? 4 is, in fact, 2 more than 2. It's double that, so that actually works. If I ask you, do you steal office supplies? Rarely to always. 4 is not, in that case, double 2. So your anchoring, your scaling matters. And then there's a measurement statistics aspect to this, where your scaling is going to affect the type of analyses you can run. And we'll talk about that a little bit here in a few seconds. But what we'll do really for the bulk of the lecture today is we'll talk about 3 properties of numbers and how those properties translate into 4 scales of measurement. The 3 properties of numbers we'll talk about are identity, order, and quantity. So numbers have these properties when we talk about psychological measurement. Numbers can have a property of identity. They denote sameness or difference. This is a simple way to measure things. You have something or you don't. You steal office supplies at work, or you don't. That's an easy way to measure your predilections towards office theft, or whatever it happens to be. The trick here is that these categories must be mutually exclusive and exhaustive. In other words, they cannot overlap, and they have to cover all possible outcomes. So, do you steal office supplies? Yes or no would have the property of identity. Yes, you do, or no, you don't. There's no maybe, there's no middle ground there. And that covers all the bases. So certain things we do, you win or you lose. If there's no tie option, let's say, that would be measurement that has identity to it. They're mutually exclusive and exhaustive. So some stuff we look at does have this. I guess, for a clinical application, you don't see this much because things are now on a continuum. It's not you have a disorder or you don't necessarily. It's you have a disorder or you have more of a disorder. We could ask things like, have you been absent from work in the last week? And it's yes, you have, or no, you haven't. So this is pretty simple, pretty basic. But if you do go this route, you want to make sure that you've got, again, the mutual exclusivity and exhaustiveness. So in this example, we could categorize these numbers, right? 4, -3, 1, 0, -2. I'm not going to read them all. Now these are numbers. They are their own numbers, but you could categorize them. And you could categorize them in this case as, actually you can't. 0 shouldn't be in there. I was going to say you should categorize them as positive or negative, but this is actually a bad example because 0 is in there. And if you say just positive or negative, it's not exhaustive because there is a possibility. So you want to be careful about things like that. And I honestly don't remember what this one was. It's a bunch of weird colors. We're going to skip past it. Something can have the property of order. It denotes the relative amount of something. So when you measure something, you can say it has more or less of something. In this case, it's not saying, here's exactly how much you have. Instead, it's saying you're somehow ordering your measurement by how much there is. Olympics, right? Gold, silver, bronze. Gold, you don't know how much better gold is than silver, or silver is from bronze, and it in fact differs from year to year or event to event. Sometimes gold and silver, the people are really neck and neck. Sometimes they're, pretty far apart. For the property of order, though, it doesn't matter. We're just saying gold was better than silver, was better than bronze. If you look at top 10 lists of whatever, American top 40, if you're listening to the radio way back when, whatever it happens to be, just ranks of individuals, we can rank people as a property of order or rank attributes. You may be smarter than your neighbor, who's smarter than the guy that lives 2 blocks down. We're not saying how much smarter. We're just ranking you on who is first, who is second, who is third. So this ranking is a property of order, even if it doesn't tell us exactly how much you have. But it is more complex than our previously mentioned identity. Now, if we want to take that a step up and take it a step further, we could do property of quantity. So this is where the number is exactly what it's supposed to represent. It's the exact amount. This can be useful. Sometimes, just to go back a sec, we want property of order. We just want to know who's the smartest person, who's the most depressed person, who's the most whatever or least whatever, in order to do something. If we're talking about admitting people to graduate school, we want the top 10 people. We don't care necessarily how good they are. We have 10 slots and we want to take the first 10 that are the best. But if you have a specific cutoff point, for example, you need to have a GRE score or a GPA of X, then you want properties of quantity. Now, you're not just using a number to label. You're not saying, 1 is male, 2 is female, 3 is non-binary, 4 is something else. Now numbers mean something. They're not just there so that our computer programs work well with them. They specifically should represent the amount of something someone has. And this is what most of the time our psychological measures do. Your IQ score represents a certain amount of intelligence you have or cognitive ability. Your conscientiousness score represents a specific amount of conscientiousness, and so on and so forth, right? This is what we often rely on. You have a certain amount of depression based on your exact score on the Beck Depression Inventory. While we sometimes use those other two, we really focus on quantifying in psychology because, frankly, as a social science, this is as best we can do, and we need to use these quantifiable numbers in order to make inferences and in order to eventually affect change in whatever domain we're working in. This also is useful because if we can quantify something, we can run statistics on it. And this goes to my point just now about making inferences. If we can put a number on something, we can then test it. We can then, we can do a t-test, we can do an ANOVA, we can do correlations, we can do these things that we can then take to others and say, look here, there's a difference, it's statistically significant, this matters. It's the same way that hard science does a lot of things. When we talk about, let's say vaccine development, vaccine developers need to go and say, we can quantify the number of people that got better or didn't, or, in the exact efficacy of the vaccine. Decision makers don't want to hear just, it worked or it didn't, or this vaccine's better than the other one. You want to be able to put a specific number on it so that you can make better decisions from there. So those are the three properties of numbers. I'm going to talk about 4 scales of measurement in a second, but we're going to have a quick sort of digression here and talk about the number 0. Specifically, the number 0 is weird, right? Because it's used so idiosyncratically in measurement. Sometimes it's the central point in a scale. We have a self-assessment scale that I hate in our department that has negative, it's on a scale of -3 to 3 of, not developed at all to very developed for your skill set. So if I asked you, how's your stats skill set? -3 is not developed at all, 3 is developed at all, 0 is essentially just the midpoint. It doesn't mean anything other than it's the middle. 0 also in some measurement scales means something doesn't exist. How many times did you throw your water bottle at a cohort mate in the last week? If you tell me 0, that means you didn't do it at all. It didn't happen. And when sometimes 0 is like weirdly, there's measurement issues. You can't really measure something that doesn't exist. That gets into like a metaphysical debate. Can you really measure something that's not there? That we're not doing here. But there's lots of examples of 0 being sort of strange, right? Temperature. Here in the United States, we use the Fahrenheit scale. What does 0 mean? It means it's cold, right? Like that's all it means. 32 is boiling, or not boiling, 212 is boiling. 32 is freezing, or the temperature at which water freezes, but 0 just means it's pretty darn cold. On the Celsius scale, 0 is where water freezes. So it has a meaning there. It's not like, it's sort of an arbitrary meaning, but there's a meaning for 0 on Celsius. And then for the Kelvin scale, if people think back to that, 0 means the absence of temperature. That's like the end of everything. So in that case, 0 implies a true does not exist. In each of these things, Fahrenheit, Celsius, Kelvin, 0 goes from having no meaning to some meaning to a lot of meaning and the implication of the absence of something. Correlations are the same. What does a 0 correlation mean? It means there's no relationship there whatsoever. Intelligence tests are weird. If you got a 0 on an intelligence test, does that mean that you are completely unintelligent? Or you lack intelligence completely? No. It may mean that there's some cause for concern here, but if you get a 0 on an intelligence test, it doesn't mean you are completely lacking in intelligence. So 0's weirdly different. Here's my advice. Practically speaking, here's the temperature thing. Practically speaking, avoid 0 unless it truly means the absence of something. Because if you choose 0, you limit yourself. If you say like, oh, 0 strongly disagree and 6 is strongly agree, and you end up wanting to multiply things together or do some other transformation, you've painted yourself into a corner, right? Because if you multiply something by 0, it's becomes 0 and you're screwed. So if you're considering using 0 in your scale, think carefully, does it mean the absence of something or not? If it doesn't, probably just don't use it, just to be on the safe side. So we'll wrap this up with, we talked about, this is very similar to our property of numbers, but more specifically, we're talking about the 4 scales or the 4 different types of measurement that we have in psychology. It's nominal, ordinal, interval, and ratio. These terms may be familiar to you from way back when, they may not be, that's okay. We'll review them real quick. So nominal is the most basic. Another way people say this is categorical. It's a property of identity. It's just assigning numbers rather than using labels or words. So, 1 or 2 for male or female, or 1, 2, and 3, male, female, non-binary, for example. 1, 2, 3, 4, 5, Caucasian, African American, Asian American, Hispanic, other, and so on and so forth. The idea, though, or the point here is that 2 isn't greater than 1, 3 isn't greater than 2. These labels are arbitrary. It's just some way to put a number or to put a measurement on whatever it is you're looking at. Why do we do this? So that we can eventually run statistical analyses on these things. We can do an ANOVA or a t-test, for example, looking at mean differences between groups on some variable we care about. It could be, we could do whatever else we want. Do you drive a car, a truck, or an SUV? You get a 1, 2, or 3, right? Totally, the numbers themselves are meaningless. They're a means to an end. Option 2 would be ordinal. And this is a property of order, back to our properties of numbers. This is a ranking. And this is basically saying, best, second best, third best, first, second, third. If you think about it, if like you ever ran track or swam or did something like that, or if you run 5Ks or whatever, ordinal would be like you placed first, second, or third. It wouldn't be about your exact time. It would just be the rankings. I remember, looking back in like the newspaper as a kid, being like, okay, who placed in what order for these events? That's, they would also give the specific time, but the ordinal number was just the placement. Another, when you were applying to graduate schools, you probably had a list of schools. Hopefully you got into grad school. You're here, so you're doing great. If you only had one option or one choice, you clearly worked out. You're here with us, and it's so great. But you might have ranked your grad school choices first, second, or third. You probably didn't have a number saying, oh, Radford's a 72, and this other program that I want to go to, I'd say, is a 78. You just had Radford as the first choice. Everyone else was the second, third, fourth, or fifth choice because we're awesome. This is useful when you want to compare people and you aren't worried about running too many complex statistics on them. This is used to figure out, who's the best, who's the worst. Now, what we often rely on is the interval scale of measurement. This is a property of order and quantity a little bit. A Likert type scale, or 1 to 5 or 1 to 7 scale, we're saying is or interval enough, right? We treat it as interval. And an interval, we assume, or we make the assumption that, 2 is the same distance from 1 as 3 is from 2. So if you go from a 1 to a 2 and a 2 to a 3, that's the same distance. Those are equal amounts. Now, this is why I said sort of, because if you think about a Likert scale from strongly disagree to somewhat disagree to neutral, we're assuming that that distance is the same between each of those. It's a little fuzzy, right? It doesn't totally work. But the point here is we need to assume stuff is interval enough to run parametric statistics on them. Or, that's a fancy term, but most of our statistics. The other thing with interval is that 0 is arbitrary. 0 doesn't mean anything in this case. So a lot of stuff we do is interval. IQ tests, the Beck depression inventory, attitude scales in social psych. Most of them, those are all interval things, right? Your attitudes towards religiosity is interval. And so on and so forth. You've got your own examples. Then the last scale of measurement is ratio. And what I'll say is that ratio is the same as interval. The interval between numbers should be the same, but it adds on that 0 is absolute. 0 means the true absence of something. Side folks, if I said that you had a 0 on the Beck depression inventory, could you say that that person is truly lacking in any depression? You could maybe try to make that argument, but I don't think it would fly great. Like, you can't say that they have none whatsoever. If someone has, a 0 on job satisfaction, does that mean they have absolutely 0 job satisfaction? Well, maybe, but maybe not. If someone, any strongly disagree or strongly agree thing for a more socially based attitudinal scale doesn't mean that you don't have any feelings about this or I don't know, like, it doesn't work. We don't often operate at the ratio level. Hard sciences and folks that work with rats, sometimes you do use ratio level. If a rat, God, this is a terrible example. If a rat you do something, you give a rat a bunch of drugs and it has a heartbeat of 0, does that mean there's an absence of heart activity? Well, in that case, yes, you've killed a rat, you monster. But you usually see this in the more science-oriented things. A time of 0.0 seconds means it took absolutely no time. But again, for a lot of psychological things, when we're measuring human beings, we don't get to ratio level. Which is, arguably a problem. The hardcore statisticians would say our behavioral data, not just in psychology, but in social sciences in general, isn't really interval and certainly isn't ratio. So it's probably inappropriate for a lot of the tests we do. I would counter argue, who cares, essentially? It's not perfect, but it's the best measurement we have, and we are able to draw strong inferences from good experimental design and things like that in order to use this information. So is it perfect? No. But is it good enough for it to be worth doing, to learn about people and help people? Yeah, it totally is. So if you ever run into a statistician and they go on and on about that, let's say you're at a cocktail party, sip your drink, nod politely, and then, like, as you're leaving, spill your drink on them. And I think that should get the point across nicely. So this, just to wrap it up, now that I've encouraged you to spill drinks on people, which I think was very mild-mannered of me for advice, there's alternative taxonomies than these for Terwilliger, which is, there's a lot of names in psychology I enjoy saying. Terwilliger might be, like, easily top 3, which would be an ordinal scale for those of you keeping track at home. He's got a different system. There's other taxonomies. I'd say if you're walking, some of this is just, you need to know these terms to sound like a competent psychologist, but practically, as you're designing your measures, be deliberate. Oftentimes 1 to 7, strongly disagree to strongly agree will work. Maybe your anchors change, never to always, But make sure if you're using something like, well, two things to make sure. One, if you're using the number 0, make sure that it's deliberate. Think through, what does 0 mean here? If it doesn't mean the absence of something, don't use it, because it'll limit the mathematical operations you can do down the road. And two, always think about, what is it that you're measuring? What does more of whatever your measure is mean? What does a 7 instead of a 1 mean? In a lot of cases, it just means you agree a whole lot more, or you endorse something a whole lot more. But you want to go through that thought process, and you want to just even say out loud, or say to your partners, okay, if someone has a higher score, what does that mean versus about them versus someone that has a lower score? You'll mostly be operating in the interval sphere. If you aren't, or you come across something different, feel free to reach out, and we can talk about what that means and if that's the best bet more. But for now, folks, that's it on scales of measurement. I will talk to you soon.